right. So we're going to find the 3 roots of 64i. The first thing you're going to do is you're going to write this 0 plus 64i. The reason you're going to do that is because now it's a complex value. It has an x and a yi. So what is the modulus of this going to be? Yeah, it's 0 squared plus 64 squared, which is just 64. What's the angle going to be of this particular one? Yeah, draw a figure here, and then 64i is up here. Well, that's just going to be pi over 2, isn't it? Okay, so now that I have that, I can write this z cubed equal to 64 cis. See that pi over 2? The only thing that's new is you're going to add 2 pi k. That's the only thing you're going to do that's new here. With your argument, you just add 2 pi k, because we're going to find multiple answers. And when we do multiple answers, k is going to be 0, 1, and 2 to get your 3. If we had a 4th power, it'd be 0, 1, 2, 3. If we had it to the 8th power, it'd be 0 through what? 7. Yeah. Anything beyond that will just repeat and get you the same values. All right, before we do, this is my secret step. Okay, the secret step is you go z cubed is equal to 64 cis pi plus 4 pi k over 2. That's the secret step. Because you get that common denominator, the de Moivre's theorem is way easier now. Okay, so let's do it. I want to get rid of this cube, so I'm going to take z cubed to the 1/3, which is also going to be 64 to the 1/3, cis pi plus 4 pi k over 2 to the 1/3. Does this make sense now? Remember doing this in honors pre-calc and you went, huh? What? And now it seems easy, doesn't it? What's the cubed root of 64? It is 4. So z is going to be equal to 4 cis. Now it's pi plus 4 pi k. And with de Moivre's theorem with the theta, what can we make this denominator now? 6. And so this is the formula that you're going to come up with the 3 roots. We're going to look at z0, z1, and z2. And this is where k equals 0, k equals 1, k equals 2. And then you just plug them in. 4 cis pi plus 0 over 6, which is 4 cis pi over 6. Next one will be 4 cis pi plus 1 times 4 pi will be 4 pi, right, over 6. What will that be equal to? 4 cis 5 pi over 6. And then the last one's going to be 4 cis pi plus 2 times 4 pi, or 8 pi, over 6 equals 4 cis 9 pi over 6. Now, on the test for IB, these look great. Are they between negative pi and pi? These two are awesome. Not so good. So we need to subtract 2 pi, and 9 pi over 6 minus 2 pi is just what? Negative 3 pi over 6. No big deal. This is just 4 cis negative pi over 2. That's all. No big one. That's no big deal. So these are my 3 values. if they wanted it in rectangular, you just expand those cosine theta plus I sine theta. Sure. Do you want to see them? Yeah. So watch this. So when we sketch these three roots of, what was that, 64I? Yuck. All it is 1, 2, 3, 4. These would be, the first one is out 4. The angle is 5 pi over 6. So I would think it's going to be somewhere like here, here, and, oh, the first one was pi over 6. So it's something like that. That's something? So it really, it does totally make sense. The technique is a little weird at first, but you'll get used to it. Try 5F. If you can do 5F, you're in great shape.